Hi guys, welcome to another episode of MrLopezClasses.com. This is our diesel engine class. This is the chapter 5, episode 4. This chapter is dedicated to types of reparations on the head gaskets, compression tests, and a torque procedure on the head bolts. Alright, the million-dollar question. Can I repair my head if the head is broken or if the head is damaged? Remember, I recommend immediately you remove the head. The first step is take pictures, of course, and after that clean the head properly. Clean the head with a mineral spirit or any other solvent at high pressure if it's possible, in order to remove all the grease. And after that, check if the head is straight with the metallic ruler. You remember? Okay. And after that, check with a liquid penetrant or magnafluence if the head is cracked or is broken. If the head is cracked, normally when you send to the machine shop, they explain to you where is located the crack, and in some cases they recommend repair the head. In marine applications, according with my experience, I don't recommend repair the heads, especially for diesel engines. I don't recommend repair heads in any type of engine, gas or diesel, marine application, because at the end of the day it's more expensive. In a couple of months you need to replace the head again. Avoid that inconvenience. Replace the head from the beginning. Don't try to fix the head. Oh, there are machine shops specialized in aluminum heads and steel head. Yes, I know. And there are special shops with excellent welders with a lot of years of experience, and probably they can fix it, the heads, for heads of older engines where it's practically impossible buy the new head. If it's impossible, the only option is try to repair the head. But if it's possible buy the head, if it's possible order the new head and replace for a new one. Yes, there are a company dedicated to fix it heads. Where is located normally the typical crack on the head is here, in between both valves. In between the intake and the exhaust valves, the head is cracked over there. This is normally for lack of lubrication and lack of coolant circulating through the head. The head is too sensible. It's easy destroy the head. All right, but I don't recommend repair the head. Cracks in cast iron heads are most often repaired by pinning, but this is a technique that, believe me, in marine application is not recommended. Soon or later you have a leak. For that reason, I don't recommend. Some aluminum heads can be repaired with a thick tungsten inert gas. Yeah, it's possible, but I don't recommend. All right. Only use welding techniques in extreme cases where it's impossible buy the part new one. I recommend repair the head. In the next of the cases, I don't recommend repair the heads. Okay, we are going to start right now to verify the head gasket. That important gasket located in between the block and the head. There are different type of head gasket. This is in my opinion, the most critical gasket of the engines because it's the gasket that keep the seal on the combustion chamber. And you remember how much are the temperatures and the pressures inside of the combustion chamber in a typical diesel engine? A lot of pressure, a lot of temperature. For that reason, the condition of that gasket is important. Once again, never try to repair the head gasket for aftermarket gaskets. Never, under any condition. This is the first recommendation. The second recommendation, always, 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 when you remove the head, replace the head gasket. No, because the head gasket lose like new one. Sorry. You remove the head, replace the head gasket. Exactly the same with the head bolt. You remove the head, you replace the head bolt. That's my recommendation. I'm going to explain right now in a couple of minutes why those head bolts should be replaced. Alright, and the head gasket should be originally. Be careful with this. In some cases, when you remove the head and the machine shop found that the head is a little bended, they cut the head, they shaved the head. In other words, when they cut the head, they reduce the value of the combustion chamber. What happens when the value of the combustion chamber is reduced? What happened with the compression ratio? Yes, the compression ratio increased. Because right now you have a small pocket on the combustion chamber. Okay, it's good idea increase the compression ratio in your engine. No, it's not good idea. The engine was calculated, was designed according with those dimensions and those specifications. If you reduce the value in the combustion chamber, probably you have a little high temperature in the regular operational temperature of the engine. Right now the temperature is a little higher, and you can introduce additional problems if you increase the compression ratio. For that reason, if you don't have experience with that procedure, the procedure to increase the compression ratio in order to increase the performance, I recommend that if you send the head to the machine shop and they cut it a little, they recommend a new head gasket with thicker value. Yeah, because with the thicker head gasket, you compensate the amount of metal that they cut it. And right now, the value in the combustion chamber is like the original. This is very important. Normally, when in good machine shops, when you send the head to the machine shop, they return the head, cut it, and they supply to you the new head gasket recommended in order to avoid future high temperatures on the engine. All right, this is very important. Mr. Lopez, but what happened when I decide replace the pistons for dumb pistons in order to increase the compression ratio because I want more compression in my engine for high performance? Yes, but you need compensate in other parts. I am going to explain later, and also in the chapter when I explain the calculation of the turbocharged, I am going to explain how to compensate that specific situation. But right now, until today, with the knowledge that you have right now, if you cut the head, you need compensate with a thicker head gasket. All right? Okay. Later, I promise I am going to explain how can you improve the compression ratio in order to improve the performance of the engine. All right. Don't forget, this is the recommendation when you cut the head. All right, the head gasket. The purpose of the head gasket is seal the cylinders in order to avoid leaks. Basically, leaks of coolant. Basically, leaks of oil. Remember, before you install the new head gasket, verify that the new head gasket is exactly the same like the old one. Verify that the holes in the old head gasket match exactly on the holes on the new head gasket. Verify that all the cavities are exactly in the same position than the old head gasket. This is a very important. I have a lot of experience with that. Some years ago I make a couple of mistakes because the head gasket lose practically the same. but one hole was black, and I damaged 2 heads because I put the new gasket, I start the engine, and 10 minutes later the head cracked. High temperature, high temperature, high temperature. When we remove the third time the head and we check the head gasket and we compare with the old one, we found that one cavity was blocked in the new head gasket and the coolant never passed through that area. Be careful with that. You need check the head gasket not 1 time, not 2 times, 5 times. Check that all the holes enter exactly in the position. All the cavities are exactly in the same position. Before you install the new head gasket, verify where are the holes for coolant and where are the holes for oil, and verify that those holes match exactly with the hole on the block and the hole on the head. You need to be 100% sure that those holes, the dimension of the holes on the gaskets are exactly the same like the dimensions on the hole on the block and the head. If not, the coolant or the oil not circulate properly. Be careful with that. This is other important recommendation. Alright, there are different type of head gasket. Today, the most common head gasket is multiple layers. It's basically like a sandwich. In the middle is a stainless steel layer, cold rolled steel, and in each side is an elastomer. Alright, copper head gasket. I love copper head gasket. Those head gaskets, copper head gaskets, are the unique head gasket that can be reused. You can reuse in the future that head gasket 2 times, maximum 3 times. The copper head gaskets are used in engines with higher compression ratio and higher performance. Normally, when you added a new turbocharger on an engine, I recommend replace the original gasket for copper gasket. Or when you increase the compression ratio on the cylinders, I recommend replace the head gasket for a copper head gasket. There are companies in the city where you have your boat, 100% sure you check in internet and you found that company dedicated to fabricate head gasket, custom head gasket, according with the original specification. I love those head gaskets. Those gaskets seal properly, especially the head gaskets that they have like O-rings around the holes. It's a head gasket with a let me try to check if I have like the picture that you have on the screen right now. Those copper head gaskets, they have O-rings around the holes. Then when you compress the head against the block, the seal is perfect and the coolant never pass through the oil cavities, and the oil never penetrate the coolant cavities. This is 100% good seal in those specific gaskets, the gasket that you have on the screen right now. Yeah, those are the head gaskets, and the graphite gaskets are excellent when your engine work at extreme temperature, high temperature. Graphite head gasket can be used on aluminum heads with iron block. Alright, there are a couple of manufacturers that they have designs of aluminum heads with iron blocks. What do you think about that combination? In my opinion, this is not good, because the thermal expansion of the aluminum is twice in comparison with the thermal expansion of the iron. And there are a lot of stress on the head gasket in that area. There are a lot of stress because the aluminum expands twice and the block half. And finally the bolts are bended. I don't like that design. The designers that use aluminum heads with iron blocks, they compensate that situation with the graphite head gaskets. The graphite is excellent in handle high temperatures, and its anisotropic properties solved that situation. I don't recommend. I recommend iron block with iron head, aluminum head with aluminum blocks, but no mix it because it's different metals, different thermal expansions. Okay, aluminum is lighter than a cast iron and expand twice. Of course, this is the problem. The quicker cycle of expansion and contraction stress on the head gasket produce a shear effect on the head bolts. This is not good. The head gasket have a Teflon and molybdenum to compensate that excessive difference in between the head and the block. All right, other type of head gaskets are in Teflon. Teflon is a very common head gasket used today in the majority of the gasoline engines. They have the new technologies. They use Teflon. It's a great material. All right, my friends. Right now we are going to try to check. In general terms, my recommendation is use original gasket. Doesn't matter what type of material is used. It is the original, use the original. Especially in marine application, my friend. Never try to fix it expensive engine with aftermarket gasket. It's not recommended. It's not good for yours, believe me. Now we are going to check the symptoms when the head gasket is damaged, when the head gasket is broken. It's because the coolant passed to the oil, or the oil passed to the coolant. The first consequence, of course, is that the gauge, the coolant temperature gauge, the temperature is higher than the normal. For that reason, you need to be familiarized with the position of the needle in your temperature gauge. You need to be familiarized where normally is located the temperature in each engine. And if in one moment the temperature of one of the engines passes the regular position and goes to the red area, you need to stop the engines immediately. You need to stop no, I am going to run the engine in idle. No. I am going to run the engines only 10 more minutes. No. If the needle of the temperature moves up a little, you need to stop immediately and verify different elements that we are going to talk later. But it's simple. Stop the engine immediately, remove the dipstick, and check if the oil is emulsified with coolant. If the oil is emulsified with coolant, the color of the oil is like a milky oil, and for sure the head gasket is damaged and the head is bended. You need to repair the engine. You need to remove the head and repair the head. This is one of the symptoms. Other of the symptom is I have white smoke. I have white smoke. The smoke is going out with vapor. This is coolant entering in the combustion chamber. Remember, if salt water enters, you don't have white smoke. The engine stops immediately. Alright? If you have white smoke, it's because the coolant is passing into the combustion chamber. And of course, you have white smoke. This is one of the consequences. Alright? Okay. And other typical part where you can identify if the oil is mixed with coolant is check in the reservoir. Check in the reservoir that you have on the picture, and verify the color. Probably right now the color is not the regular green or orange. The color right now is like a brown. It's because the coolant is mixed with oil. And probably if the engine was running with high temperature, you have in the radiator cap, the cap of the expansion tank, you have vapor coming out, you have bubbles coming out. This is another indication that the head gasket was blown. Alright, this is the typical scenario. This is the procedure to verify that you have a problem with the head gasket. And now I need to be 100% sure that the problem is on the head gasket. In order to identify if the problem is on the head gasket, or if the problem is on the rings, or if the problem is on the valves, those three situations produce low compression. In order to identify where is the problem, on the head gasket, on the rings, on the valves, we are going to do the compression test, and we are going to verify where is the problem, in what cylinder is the problem. In the procedure for the compression test, the most important part, once again, is check if you have the manual appropriated for that engine. And let me explain something about the procedure to do the compression test in a diesel engine. Verify if you have the appropriated tools, the appropriated specific tool in order to do the compression test for that specific engine. In order to do the compression test, we are going to remove the injector. Remember, the injector have normally in one side the input of the fuel and the return on top. The return on top of the injector. The return of the fuel, 80% of the fuel, return on top into the fuel tank. The input is in the side of the injector, 20% of the fuel enter over there, and 80% of the fuel return on top into the fuel tank. Alright, you need to disconnect carefully the input and the return using the appropriated wrench. And right now, you can remove the bolt. Normally, one bolt keep the injector against the block, against the head. Alright, right now, you need to verify if you have the tool appropriated to remove the injector. Because normally those injectors are completely seized, completely like welded with the head. Remove the injector is not easy. In general, you need to use appropriated tools recommended by the manufacturer to remove the injectors. Don't try to remove the injectors with hammer, with the vice grips. No, never try to apply the torch. Never try to apply heat on the injector, because you destroy the O-rings. You destroy the internal elements on the injector. You damage the injectors. The injectors, if you use the torch, you destroy the injectors. All right, never try to use the torch. Okay, you need to be 100% sure that you have the set with the tools, with the sockets appropriated to remove the injectors and replace the injector for the appropriated tool. You can replace the injector for the appropriated tool with the same external diameter in order to fill exactly the same hole that the injector occupied. You remove the injector and you introduce the tool in the same hole, and that tool, in one end of the tool, is connected with the pressure gauge. The pressure gauge is connected on the tool, and the tool should be attached to the head by bolt or by pressure. There are different type of tools. If you have that tool and you have the pressure gauge appropriated, you can do the test procedure. If not, never try to do the compression test if you don't have the tool appropriated to remove the injectors and the tool appropriated to replace the injector and connect the pressure gauge. All right, this is the most important part. And this is the most difficult part. The most difficult part is remove the injectors and install the tool appropriate for that specific engine. If you have the set with the tools, you can replace the injector for one of those elements on the set, and you can connect the pressure gauge. And right now we are going to follow this procedure. This is the procedure that we are going to follow cylinder by cylinder. Okay, when the tool is inserted into the hole where the injector was located before, we are going to fix that tool properly, and right now we are going to crank the engine 4 times, 5 times until the pressure reach the maximum pressure recommended for the manufacturer in the manual. Once again, if you don't have the manual, don't try to do that procedure. In the manual, the manufacturer recommend the pressure that you have on the screen right now. This is the pressure recommended for that specific injector. And right now, we are going to crank the engine 1, 2, 3, 4, 5 times until the pressure reach the pressure recommended for the manufacturer. And we are going to create a table like this. We are going to do a table like this. Suppose that we are going to put a small example here, and we are going to verify. We are going to put here cylinder 1, we are going to put cylinder 2, cylinder 3, and cylinder 4. Suppose that the engine is 4 cylinders. It's exactly the same for 6 cylinders, 8 cylinders, 10 cylinders. It's exactly the same. And we are going to check. Suppose that the pressure recommended for the manufacturer should be around 600 psi. It's an example. And we are going to check. We are going to do 2 attempts. This is the attempt number 1, and this is the second one. Okay, in the first one, in the cylinder number 1, I have 550, and in the second attempt, 560. All right. Cylinder number 2. Cylinder number 2 is 400 and 380 psi. Cylinder number 3 is 400 and 350. And cylinder number 4, 600 and 620. This is an example. This is a typical example. Okay. What happened in that particular engine? What happened in cylinder number 2 and cylinder number 3? In cylinder number 2 and cylinder number 3 are below the pressure recommended for the manufacturer. The compression in those 2 cylinders is lower than the pressure recommended for the manufacturer. Now we need identify if the problem in those cylinders is because the rings are broken or wear, or because the valves don't close properly, or because the head gasket is damaged and you have a leak. In other words, we are going to verify if the leak is through the piston rings, or if the leak is through the valves, when the valves don't close properly, or if the leak is through the gasket in between the block and the head. We have 3 possibilities: rings, or valves, or head gasket. How can we identify where is the problem? It's simple. In this particular example, we have 2 cylinders with problems, and we need to identify if the problem is on the rings, on the valves, or on the gasket. Let me explain something. Suppose that, like this, I have 1 cylinder with low compression. Okay, I am going to remove the compression test element, and we are going to add a little amount of engine oil, motor oil, the same oil that you use regularly in that engine. And we are going to introduce a little 0.5 ounce of oil. What is the function of the oil? The oil goes into the head of the piston and seal around in between the cylinder and the piston head. And now we are going to install again my compression tester, and now we are going to crank the engine again. And we are going to verify, oh, the compression right now is 650. The compression increased. Alright, where is located the problem in that cylinder? On the piston rings. Yeah, because the oil sealed the gap in between the cylinder and the piston head with oil. And right now, the compression increased. I am 100% sure that that cylinder have a problem with the piston rings. Yeah, we need to replace piston rings, or we need to hunt the cylinder. This is the next project, and we are going to replace the piston rings. Okay, what happened if I added the oil on the hole and I connect my compression tester again, I crank the engine 5 times and the compression continue low, 350, 380. The problem is on the valves. One valve stay open, or one valve is cracked, or one valve was melted, or one valve stay open all the time because the spring is broken. The problem is on the head. Or what happened in this particular example? I have 2 consecutive cylinders with low compression. I have 2 consecutive cylinders with low compression. This is a perfect indication that the problem is on the head gasket. When you have 2 consecutive or 3 consecutive cylinders with low compressions, it's because the head gasket is blown, because the engine was overheating, the head was bended, and the head gasket was flooding, and the oil passed into the coolant. 100% sure that in this particular engine with 2 or 3 cylinders adjacent with low compression, if I check the oil, probably the oil is a milky oil. The oil is emulsified with coolant, and the color is the color that you have on the screen right now. This is an indication that the head gasket was blown because overheating for some reasons, other mechanical reasons that we need to identify. And right now the compression is low in those 2 adjacent cylinders or 3 adjacent cylinders. Okay, we are going to summary the information. In order to do the compression test, we need, first step is keep the manual appropriated according with the serial number and the model of the engine. The second one is be 100% sure that you have the tools appropriated to remove injectors and install the new tools over there, and verify that the tools are appropriated according with the diameter of the hole on the head. Now install the tools appropriated, install the pressure gauge appropriated, crank the engine 4 times, 5 times, and verify the maximum pressure on the gauge of the pressure gauge. Alright? And copy that number in the table and repeat the procedure 1 more time per each cylinder. In other words, it's 2 times per cylinder. Copy all the information in the table, and after that analyze the situation. I have only low compression in 1 cylinder. Okay, let me check if the problem is on the valves or on the rings or on the head gasket. Alright, let me add a little amount of motor oil, and now I install again the compression tester, and now I crank the engine again. Oh, the compression increased dramatically. Alright, the problem is on the rings. Oh, I added the oil and I crank again, and the compression stay low, low, low. The problem is on the valves. Oh, I have low compression in 2 or 3 adjacent cylinders. This is a typical problem of the head gasket. The head gasket is blown for some reasons. We need to remove the head, send the head to the machine shop in order to cut the head and replace the head gasket, and try to start the engine again and verify if the problem was solved. Okay, my friends, this is the procedure to calibrate the valves, and this is the procedure to do the compression test in a typical diesel engine. Okay, and finally, after the compression test, we are going to put it back the head, and we are going to torque the head properly. Once again, we are going to torque the head. First question, do you have the service manual? That's the most important part. You have the service manual, and now check where, in what page are located the torque specifications specific for the head, and verify what type of head bolts you have. You have a 12 points sockets, you need a 6-point sockets, you need a Allen sockets. Yeah, verify what type of sockets are the sockets recommended for that specific head bolts. Verify if you have the torque range. Normally for diesel engines you need half, 3/8 is not enough. Okay, verify that you have the sockets, verify that you have the torque range. You can use any type of torque range, click or digital. Both of them are accurate. I recommend both of them. Try to use a good brand. Believe me, if you use cheaper torque wrenches, you have different measurements. Alright, other important recommendations. Try to replace the bolts for original bolts, new ones. Can I replace a couple of bolts for all the head bolts? Use standard bolts, but 2 of those bolts are broken. Can I replace only 2 of those bolts? But can I replace those 2 bolts for standard? The rest of the bolts are metric. No. You need to replace all of them, and you need to use exactly the original specification. If the originals are standard bolts, use standards. If the originals are metric, replace for metric. Never try to mix it. That's the most important. If for some reason it's not possible to find the new bolts, the original bolts, for example standards, and you found that the similar bolts metric, yes, you can replace all of them for metric, but I recommend try to repair the threads. Try to pass the new tab in order to be 100% sure that the threads are exactly the same like the bolts that you have. The procedure is simple. I explained in our class of introduction the procedure. You need to select the tab appropriated according with the type of threads on the head bolts, and rectify the threads. This is very important. Alright, be careful, check the specifications, check the procedure recommended for the manufacturer in order to apply the torque appropriated. There are manufacturers that they use 1 step, 2 steps, 3 steps in order to do the procedure. Follow the recommendations of the manufacturer, specific for the number of steps or the procedure to apply the torque. If you don't have that information, you only know what is the maximum torque recommended for those head bolts, I recommend use the spiral procedure, like the picture that you have on the screen, starting in the middle and finishing on the sides of the head. This is a good technique. Normally when I don't have the information, if I am working in the middle of the ocean and I only know the maximum torque, I use that spiral recommendation, or in zigzag, like other manufacturers recommend. Okay, but the spiral recommendation is good. You start in the middle and you follow the spiral path until you finish on the side of the head. And for example, if the torque recommended, the final torque is 120 foot-pounds, for example, I recommend start with 40. You calibrate your torque range in 40, and you start according with the procedure 40, 40, 40, 40, 40. After that, you increase 80, 80, 80, 80. After that, 100, 100, 100, 100, and after that, 120, and you finish in 120. This is my recommendation. Some manufacturers, they recommend the torque with the torque range, and after that, with the angle tool, apply 90 degrees additionally or 120 degrees additionally. For that reason, I recommend follow the recommendations, the torque recommendation of the manufacturer. The service manual is mandatory. If you don't have the service manual, don't try to do any type of reparation. If you have the service manual, you follow the recommendations and you don't have any problem. All right? No, because a friend of mine, no friend of mine. The friend of mine is the service manual. All right? This is the procedure. Don't use when you apply the torque. Use impact tool sockets, and never use extensions, because if you use extensions, you modify the torque recommended. In some situations, is because it's not possible access the bolt, you need an extension. I recommend, if you use an extension, added 10% additional torque. If you use an extension, if you use an extension, added 10% to the recommended torque. Never use all bolts. Replace the bolts for new ones, and install the bolts dry, no wet. Never impregnate the bolts with oil. Install the bolts dry. Why? Because if you apply oil on the threads, with the vibration on the engine, the bolts will be loose in a couple of years. I don't recommend use oil. I prefer that you install the bolts dry. All right, this is the final episode of the chapter 5.